LeetCode Problem 102, Binary Tree Level Order Traversal. So this problem gives us a binary tree, and we have to return the level order traversal of its nodes value, right, from left to right and then level by level. Okay, so what that means is, in this binary tree, for example, the output will be the first list containing 3, which is the only node in the root. After that, on the next level, we will have 9 and 20, and then followed by 15 and 7 over here. Now, if this 9 node, has 2 childs, let's say 1 and 2, then this list will be 1, 2, 15, and 7, right? Because on this level, there are 4 nodes. But in this case, there is no such nodes, so it will only be 15 and 7. But just keep that in mind. Okay, so my approach to this problem is to use something similar to a breadth first search method, where we go level by level, exploring every child of its node, right? Okay, so to do that, I'll explain how, but I'm also going to use a queue. This is basically to put in the nodes that we are going to traverse from left to right. Alright, so this statement basically checks if the root is null, we will just return a empty vector. Otherwise, here I initialized a result vector. This is what we are going to return, and then a queue, which is what we are going to store the individual nodes, right? And then storing based on the left to right, right? So you store from left to right. So here in my queue, I'll push the root. Okay, do know that queue is first in first out. So if I keep pushing, it will be put at the back here, and when I pop it, I'll be popping from the front. Okay, alright, and then here, while queue is not empty, in this case it's not, so what happens is I track the size, right? So this size is equals to queue's size, and here in my vector, I will initialize an empty vector. This is an empty vector that we are going to push into our result per level, right? So I have another for loop. This is iterating through every single node in this current level, but currently there's only one node, which is 3. So 3 node is equals to queue front, so queue front is popped. So I will just remove it here, and then I'll put the node is front is 3, right? Okay, we pop it. Then we push back the node value, this is 3, right? So I'm going to have another one called result. Here, result equals to this, and then the vector is going to this, right? So this vector is over here, this result is over here, right? Currently it's empty. Okay, vector pushback node value, so vector pushback node 3. Alright, so now we check whether or not this tree has left and right child, right? So in this case it does, has 9 and 20. So we push the left node, push on 9, and then on the right we also have to push our 20. I don't think I need to do this. Let me just do this instead. Okay, then since my size here was 1 because of the current level, I exit this for loop and I push back the vector we have into our result. So now it looks something like this, right? Okay, then we iterate through again while vector is while the queue is not empty, which in this case is not. So size is equals to queue size. Our queue size is 2. Okay, we initialize a empty vector here, and then we're iterating 2 times, right? So I is less than 2. Okay, the node is q front, node is currently 9, right? We pop, we remove the top one, so q looks like this. Our node is currently 9, and on 9, 9 does not have left and right child, right? So we don't have to do anything here. Okay, after that we iterate again, and now node is our front is 30, and then we pop up here, and then we push back our 30. Right, just now I forgot to push 9 here, but then there's a 30 here. Oh, sorry, 20. It's 20, not 30. Okay, 20. So in this case, our 20 has left and right node. Right, have left node. It has a left node, so here we have to push in 15, and we have to push in 7 also, right, because it has a left node. Okay, and once that's done, we've finished iterating through the for loop. We push back the vector we have into our result, like so, and then we start over again, right? So the queue is still not empty. There are still nodes inside, so our size is still 2, right? There's 2 nodes, empty vector, and then iterating through for loop, iterating through the nodes in the queue. Node equals to node front, so node front right now is 15. Pop it. Okay, so 15 does not have left and right child. Technically it does, but it's a null node, so we don't do anything. We push 15 into our vector, and then we iterate through again. So now our node is 7. Pop Q, push back 7, and then same with 15. It does not have a left and right node, so we can exit this for loop and then push this back to our result. And once that is done, we exit this while loop. Exit this while loop because now our queue is empty. As you can see, it's empty right now. And then we return the result, which is 3, 9, 20, 15, 17, right? Okay. So let's say just now, uh, 9, 20. Okay, let's start over instead of being confusing. So let's say, okay, let's say now 9 has 2 more nodes, 1 and 2, right? So how would that look like? Okay, so again at the beginning we push the root, which is 3, then it's not true, it's not false, but it is false, so if you enter this while loop, size is 1, blah blah blah, we push in, we pop the q, push in our 3, and then technically we don't need to, you have to do this, right, because we q and push back, and then we put our left and right node, right, in this case it's 9 and 20, so 9 and 20. After that, we exit this for loop and then push back into our result. I'm just gonna quickly speed this through because we've done it before. Okay. Now that we have 9 and 20, so when we return to this for loop, our size is now 2. There's 2 nodes here, so 9 and 20. Empty vector. Start a new for loop. Right, so node equals to q front, so node is now 9. And then we pop. And then we push back 9 here. And then check whether or not 9 has left and right node, which in this case it does, 1 and 2. So in my queue, I'll have to put 1 and 2. Right, so the queue looks like this now. Okay, and then for the next one, we have 20. 20 here, pop here, push here. Okay, and 20 have left and right node as well, 15 and 7. So push here, 15 and 7. Okay, once that is done, exit this for loop, push back the vector. Vector is 9 and 20. Okay, and then you can see here now we have 1, 2, 5, 15, and 7. And long story short, none of them have any child, so all of these will be moved into the new vector, which is what we will push into our result, right? I'm not gonna do the entire process again now because it's the same thing. Okay, once that is done, all of the exits, we return the result, which is correct, right? 3, 2, 3, 9, 20, 1, 2, 15, and 7. Okay, so that's all I have to show.